We're tackling the problem maximum subarray, a relatively famous problem which we want to try and solve with minimum complexities of on in time and O1 memory. The maximum subarray problem asks us to find the contiguous subarray within an array of integers that has the largest sum. We need to return the sum of this contiguous subarray. The options for the optimal solution here are A. Greedy, B. Sort and sum, C. Kadane's algorithm, or D. Divide and conquer. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get it, congratulations. And for those of you who just need to see some code, the answer here is C. Kadane's algorithm. And I'd strongly recommend checking out the course in the description if you don't already know this. Our brute force approach is very simplistic compared to the famous algorithm. We can consider all possible subarrays and calculate their sums. That would have a time complexity of on squared, and obviously won't do when we've got such a better option available, Kadane's algorithm. Let's walk through the optimized solution, which is based on that algorithm. So this uses the insight that for any given index, the maximum subarray sum ending at that index is either the element at that index itself, or the sum of the maximum subarray ending at the previous element plus the current element. That is, the maximum sum ending at the previous index plus the current element. By keeping track of the maximum subarray sum ending at each index, we can determine the maximum subarray sum overall. So, to completely ensure understanding here, let's go through this line by line. First of all, SZ is simply the size of our input vector nums, and we initialize the variable result. In C++, we're using int min, the minimum possible integer value, and this will be used to keep track of the maximum subarray sum we've found so far. Max so far is initialized to 0, and this variable will store the maximum subarray sum ending at the current index. After that, we've got a line that simply iterates through each index of our nums vector. And within that, we've got two really key lines. The first is here, line 9. This calculates the maximum subarray sum ending at the current index. It takes the maximum value between the current element, which is nums I, and the sum of the maximum subarray ending at the previous index, that is, nums I plus max so far. This comparison ensures that if the sum of the previous subarray is negative, we start a new subarray from our current element. Line 10 simply updates our result variable, updating it with the maximum subarray sum found so far. We're taking the maximum value between the current result and max so far. This ensures that result always stores the maximum subarray sum overall, and probably won't be int min. After we've iterated through nums, we can return result, which will represent the maximum subarray sum. So, I hope that that's helped, and that is one more coding session completed with Coding Card Sharp, where we've used Kadane's algorithm to help solve the maximum subarray problem. There's a little explanation as to why we use Kadane's algorithm instead of the other methods, and if you need further help, our application also provides the code in Python and Java. Although I'd strongly recommend that you learn the method rather than just learn how to memorize the code itself. If you still need help with understanding the method, I will point you in the direction of this Udemy course, which is in the description to the video. Dr. Ibrahim goes into some detail about Kadane's algorithm, and indeed offers some variations on the same problem later on in his course. In any case, thank you very much for watching, and I hope that that's helped you with this problem.